Hello everyone, my name is Ankit Verma and today we are learning underfitting and overfitting. To understand this, we are taking the first diagram in which we are having the x-axis and the y-axis, and there are various data points. Now let us suppose that through this data point we are drawing a line. Here we can observe that out of various data points, there are only 3 data points which are covered by this line. So this is called underfitting. The meaning is we are having various data points and out of that we are covering only 3, means very limited. So we are not covering all the data points, that is called underfitting. To understand this, let's take an example. Let us suppose that we are having a ball. Now we are training our machine learning model that whenever a object is given and that is in spherical in shape, then that will be considered as the ball. So here we have taken only single property or the attribute to find it as a ball. So our model is trained. Now we are going to give the input to the machine learning model. So this time we have given the input as a orange. Now machine learning check the attribute that this is a sphere and machine learning model assume that this is a ball. But this is wrong. Here we can see that we have trained the model using only one property or the attribute, which is sphere. Ball is a sphere, orange is also a sphere. That's why the model given the decision that it is a ball. We must have more attributes or the properties so that machine learning model can take decision accurately. So that means this is underfitting. We are taking less number of attributes for training the model. Now we are taking another diagram where we are having x-axis and the y-axis, and there are certain data points. Now we are going to join these data points, and here we can see that our model is going to join all the possible data points which are possible over here. This is called overfitting. Meaning is that we are having certain data points and we are trying to cover all the data points. We want to achieve the complete accuracy, and to achieve that, model is becoming more complex. This is called overfitting. To understand this, we are taking the example. Let us suppose that we are having a ball, and to train the model, we are taking various attributes or the properties, like the first one is sphere, means object will be a ball if it is a sphere. Second is eat, means we cannot eat a ball. Next attribute is play, means we can play with the ball. Next is size, means a ball should be of specific size, let's say the radius of 5 centimeter. Now we are going to provide input to our model. Here we have taken so many attributes or the properties, so model is checking for this input. It is a sphere, we cannot eat this, we can play with this, but the size is very large as compared to the training data. So model concluded that this is not a ball. But this is wrong. This is a ball of some large size. Here, because we have given so many attributes or the properties, that's why model is confused. This is called overfitting. So here we have learned if certain properties are there and we have opted only few properties, and because of that the result is not accurate, this is called underfitting. And if there are various properties and we have picked all the properties, because of that model is confused and not giving the accurate result, this is called overfitting. Now we are understanding the difference between underfitting and overfitting. In underfitting, we have taken very less properties or the attributes. That's why model is not complex. But in the overfitting, we have tried to take all the attributes. That's why model is very complex. Next point is underfitting is high biased. Here we can see that it is ignoring all the data points and going by its own. So it is very high bias. On the other side, in overfitting, there is high variance. Here we can see that it is trying to cover all the data points and there is so much variance. Next point is underfitting is not accurate for training set. On the other side, overfitting is accurate for training set. Here the meaning is the first one, not accurate for training set. In overfitting, we have used only one parameter or the attribute for the training. So the training set is the ball, and even this ball if we give to the model, the answer may be wrong because we have taken only single attribute. So even on the data set from which we are training the model, then the model may be inaccurate or not accurate. So this is not accurate for training set. On the other side, in the overfitting, we have taken the ball for training. So this is the training set, and here we have taken various properties or the attributes to train the model. So if we are giving this data set again, the model will be accurate, means give the correct result for the training set. So we can say that in the overfitting it is accurate for the training set. In underfitting we are having only few features. So we can say that there are less number of features. But in the overfitting it is trying to cover all the features. So there are large number of features. Next thing is in underfitting, as there are very less features, that's why the training required is very less. So there is less training. On the other side, in overfitting, it is trying to cover all the features, and in that case the training required is very high. So there is large training. So these are the difference between underfitting and overfitting. Now we are learning that how to overcome underfitting. These are the points of underfitting. Just do the reverse. So to overcome the underfitting, we should increase the complexity of model. We should reduce the biasness. We should increase number of features. We should increase the training. So by doing the opposite, we can overcome underfitting. Now we are learning how to overcome overfitting. These are the points of overfitting. Just do the reverse to overcome overfitting. The complexity of model should be reduced. The variance should be reduced. The number of features should be reduced, and training should be reduced. So by this we can overcome overfitting. There is one more diagram here where we are having x-axis and the y-axis. There are data points. Here we are drawing a curve which is trying to cover the maximum data points. This is called best fitting or accurate fitting. Both underfitting and overfitting are not good because in the underfitting we are taking very less properties or the attributes, And in the overfitting, we are taking more number of properties or attributes. In both the cases, the results are not accurate. So here the best is best fitting. Means we should take those number of attributes which are really required for a system to be trained. So that's all for today. Thank you.